Ever been stuck in like a super noisy room and you just want to like isolate one voice? Or have you ever wanted to like pluck out a specific instrument from a song?
Oh, totally.
That's like the whole idea of target sound extraction.
Yeah.
And today we're taking a deep dive into this new approach called CrossMamba.
You know what's really interesting about this research?
What's that?
It's all about the balance between like accuracy and efficiency. Existing methods, especially those using transformers, they can be computationally expensive.
Oh, I see.
It's kind of like using a super high-powered engine just for a short commute.
Oh, yeah, you get there, but you're guzzling a ton of fuel.
Right, exactly.
So you're saying that CrossMamba is aiming for something a little more eco-friendly,
Yeah,
like a more sustainable approach to sound separation.
exactly. CrossMamba, it builds upon a newer type of neural network
Okay.
called Mamba.
Mamba, okay.
And Mamba is known for its speed and efficiency,
Uh-huh.
but it wasn't actually designed to handle complex relationships
I see.
between different types of data, and that's crucial for actually isolating specific sounds.
Right. So how do they bridge that gap? What's the secret sauce here?
Well, the researchers, they figured out a way to combine the speed of Mamba with a key element of transformers
Okay.
called cross-attention.
Okay.
And they achieved this by basically rewiring Mamba's internal workings
Interesting.
to process multiple like input streams at the same time.
So they're taking like the best of both worlds, kind of.
Yeah, exactly.
But how does that actually work in practice?
So imagine you have a detective, right?
Okay.
And they're searching for a suspect
Mm-hmm.
in a crowded city.
All right.
And the detective has a clue.
Okay.
Let's say it's like a photo,
All right.
which helps them focus on specific features.
Got it.
CrossMamba actually uses a very similar approach, mathematically speaking.
Oh, so the clue is like a guiding principle,
Yes.
helping CrossMamba zero in on the right sounds.
Exactly. The clue is what acts as a query
Mm-hmm.
that guides the attention of the model.
Okay.
And then it's compared against the keys,
Okay.
which represent different parts of the audio mixture.
Right.
And then the values, which have all the detailed sound information, are used to extract the target sound.
That makes sense. But we're dealing with sounds here,
Right.
not images.
Yeah.
So how does CrossMamba translate this visual analogy into like the realm of audio?
Well, it all comes down to the way that CrossMamba analyzes and compares the different input sequences. Think of it like this. You have a massive library full of books.
Okay.
Right. And the query is like a specific topic that you're interested in.
Right.
And the keys act like the index cards,
Uh-huh.
each one pointing to a particular book, or in this case, a specific segment of the audio.
Right.
And the values are the actual content of those books,
Oh, I see.
the rich details of the audio itself.
So by using the clues strategically, CrossMamba can quickly sift through this complex soundscape
Yes,
and pick out the sound we want.
exactly. And what's really cool is that it can achieve this with way less processing power than the traditional methods.
Wow.
And that opens up some exciting possibilities.
That's pretty amazing. So they took this like souped up Mamba
Uh-huh.
and they put it to the test, right?
They did. They tested it by swapping it into two established sound extraction models.
Oh, wow.
A VSET former,
Okay.
which uses like visual cues like lip movements,
Oh, interesting.
and waveformer, which uses sound class labels.
Okay.
And the results were pretty impressive.
All right, drum roll, please. How did it perform?
Well, in both cases, CrossMamba got equal or even better sound quality than the original models,
Wow.
but with like a fraction of the computational cost.
No way. So you're telling me it can be used on everyday devices?
Exactly, like smartphones,
Wow.
hearing aids,
That's amazing.
without draining the batteries.
That's a huge win.
It is.
Less processing power, better results. Where do I sign up?
Right.
But okay, let's take a step back.
Okay.
Break down exactly how CrossMamba achieves this.
Okay.
It all starts with the internal workings of Mamba, right?
Yeah, at its core, Mamba uses a selective state space model.
Okay.
And this model is excellent at capturing patterns within a single sequence of data.
Like analyzing one audio stream.
Exactly. But like we said before, the original Mamba wasn't designed to handle those crucial relationships between different types of data.
So it's like having a high performance engine that can only run on one type of fuel.
That's a great analogy. And to overcome that, the researchers, they dug deep into the math of Mamba.
Okay.
And they discovered that hidden within these equations was a concept that could be adapted to mimic the cross-attention mechanism of transformers. They basically reinterpreted Mamba's whole framework by defining these query, key, and value components.
So they found a way to rewire Mamba
Yeah.
to make it multilingual, so to speak,
Exactly.
to process information from both the audio and the clue.
You got it. And the original Mamba was already efficient.
Yeah.
But by adding this cross-attention capability, it's like they gave it superpowers.
I think I'm starting to get it, but my brain is definitely craving a little bit more concrete detail.
Okay.
Can we take a closer look at how they actually pulled off this mathematical magic trick?
Absolutely. Let's unpack those equations.
Okay.
And see how they transformed Mamba into this cross-attention powerhouse.
Perfect. But before we dive into that rabbit hole, let's give our listener a moment to catch their breath. We'll be back in a flash to unravel the mysteries of CrossMamba's inner workings. Hashtag TTS, the Deep Dive episode 2025-0301, part 2 of 3.
Welcome back. So let's roll up our sleeves.
Okay.
And take a closer look at the math behind CrossMamba.
Okay.
Remember how we talked about Mamba using that selective state space model?
Yeah, that's how it efficiently analyzes patterns within a single data sequence.
Right.
But to incorporate the clue and make it work for sound extraction, they had to tweak that model, right?
Exactly. So the original Mamba,
Okay.
it uses equations to describe how the state of a system evolves over time.
Okay.
Imagine a swinging pendulum.
Okay.
Its state is determined by its position and velocity.
Okay, got it.
At any given moment.
I'm picturing it.
Yeah.
So Mamba is capturing that movement mathematically.
Right.
What did they change to give it this cross-attention superpower?
So the key is really in how those equations incorporate the clue.
Okay.
In the original Mamba, the model adjusts its parameters based only on the input sequence,
Okay.
like the audio signal.
Okay.
But with CrossMamba, they cleverly introduced the clue into these equations,
Interesting.
allowing it to guide the model's focus.
So instead of just reacting to the audio, it's now using the clue to proactively seek out the target sound.
Yes. Think of it like this.
Okay.
You're searching for a specific book in a massive library, right?
Right.
The clue acts like a librarian who points you towards the right section.
Oh, that's a good analogy.
Saving you tons of time and effort.
I'm starting to see how this all comes together.
Yeah.
But how does CrossMamba actually connect the clue to the audio in those equations?
So they do this by breaking down the process into those query, key, and value components that we talked about earlier.
Right.
The query, which comes from the clue, acts as the search term.
Okay.
The key represents different parts of the audio.
Okay.
And the value holds the detailed information about each audio segment.
So the query helps CrossMamba quickly find the relevant keys within the audio, and then it can access those detailed values to isolate the target sound.
Precisely. So they reinterpreted Mamba's internal workings by incorporating these components into its equations.
Okay.
It's like they took a powerful engine and they added a precision navigation system.
I love that analogy. But I have a confession.
Okay.
I'm more of a big picture person.
Okay.
Can you give me a real world example?
Sure.
Of how this translates into a tangible benefit?
Let's go back to that noisy room scenario.
Okay.
Imagine you're wearing hearing aids.
Okay.
Powered by CrossMamba.
Mm-hmm.
You're trying to have a conversation with someone.
Right.
And the clue is their face.
Okay.
CrossMamba can use that visual cue to isolate their voice, even if there's lots of background noise.
Wow, that's a game changer for people with hearing impairments.
Absolutely. And the beauty of CrossMamba is the efficiency.
Right.
Traditional methods would need a ton of processing power to do this level of sound separation.
Yeah.
Which would drain your hearing aid battery super quickly.
Yeah, that makes sense.
But CrossMamba can do it with much less energy consumption.
So it's not just about the quality of the sound extraction.
Right.
It's also about making it practical.
Exactly. This efficiency is what makes CrossMamba so exciting.
Yeah.
It makes it possible to use this technology in different devices
Uh-huh.
without sacrificing performance or battery life.
So we've established that CrossMamba is powerful.
Yes.
And efficient.
Yes.
But how does it actually measure up against those existing models?
Okay.
Did those real-world tests prove its effectiveness?
They did. Remember those two models they tested, a AV setformer and waveformer?
Yes.
Well, in both cases, CrossMamba matched or even exceeded the original models in terms of sound quality.
That's impressive. So they took an already great technology and made it even better and more efficient at the same time.
Yeah, that's a great way to summarize it. But what's even more exciting is the potential for CrossMamba beyond just sound extraction.
Okay, now you're really piquing my curiosity. You're telling me that this technology has applications beyond just audio.
Remember how CrossMamba is all about finding relationships?
Yeah.
Between different types of data, that principle can be applied to a ton of different fields.
Okay, my mind is racing now.
Yeah.
Can you give me some concrete examples?
Imagine using CrossMamba to analyze medical images.
Okay.
and genetic data
Oh,
simultaneously
wow.
to give more personalized diagnoses
Okay.
or understanding complex environmental data
Mm-hmm.
to better predict natural disasters.
Wow. The possibilities seem endless. From healthcare to environmental
It
science,
really is.
this technology could totally revolutionize the way we analyze and understand data.
It's a really exciting time to be working in this field.
It sounds like it.
The researchers behind CrossMamba have basically opened up this new avenue for data analysis,
Yeah.
and I can't wait to see how it evolves and impacts different industries in the coming years.
This has been an incredible journey so far.
It is.
Uncovering the magic behind CrossMamba.
Yeah.
We've delved into the technical details, understood this innovative use of the query, key, and value system, and even glimpsed the vast potential applications.
Yes.
But before we get too carried away with future possibilities,
Okay.
I think it's time to pause for a moment.
Okay.
When we come back, we'll shift our focus to the broader impact of CrossMamba,
All right.
discussing its potential benefits and challenges as it moves from the lab into the real world.
Sounds good.
Don't go anywhere. Hashtag TPS The Deep Dive episode 2025 OTR1 Part 3 of 3. Welcome back to the Deep Dive. We've been unpacking this awesome new approach to sound extraction called CrossMamba.
Yeah.
But it's pretty clear this technology has implications that reach way beyond just audio.
Yeah, you're absolutely right.
So we've been hinting at the principles behind CrossMamba.
Uh-huh.
This ability to connect different types of data using the query key value system.
Right.
That's a pretty powerful thing.
It is.
With applications in a ton of fields.
Yeah.
So less about isolating bird songs.
Right.
And more about changing how we diagnose diseases or predicting earthquakes. You made some pretty bold claims before the break.
Let's take healthcare as an example. Okay. Imagine you're a doctor
Okay.
trying to get a complete picture of a patient's health. Traditionally, you might look at medical images,
Okay.
genetic tests, lab results, all these separate pieces of data.
So it's like trying to solve a puzzle, but the pieces are scattered all over the place.
Exactly. But with CrossMamba,
Okay.
you could potentially analyze all of this data simultaneously.
Oh, wow.
The query could be a specific medical question.
Okay.
The keys would point to relevant data points across all those different sources.
Right.
And the values would provide the detailed information needed to make a diagnosis.
It's like having a super-powered medical detective.
Yeah.
That can connect the dots.
Right.
And uncover hidden... Hey there. Want to share your thoughts on this?
It seems that the attention from the Mamba have a soft plus function. What's the meaning of the soft plus function?
That's a great question.
Yeah, let's unpack this.
That soft plus function is like a smoothed out version of another function
Which is?
called real U, or rectified linear unit.
Okay.
Real U is pretty simple. If the input's positive, it outputs the same value. If it's negative, it outputs 0.
Gotcha.
Soft plus makes that transition a bit smoother.
Why smoothing out?
In the CrossMamba paper, it's used when calculating some parameters in the Mamba part of the model.
Right.
Specifically, it helps determine how much of the past to remember when processing the audio.
Oh, I see.
By using soft plus instead of ReLU, the model avoids sudden jumps in those parameters.
Makes sense.
And that helps with stability and learning.
So it's all about fine-tuning how the model focuses its attention.
Exactly.
And as we were saying before, that ability to connect different types of data is pretty powerful stuff.
It is.
That might be missed by looking at each piece of data in isolation.
Exactly. And the applications go beyond just diagnostics.
Okay.
Think about real-time monitoring.
Okay.
In critical care units, CrossMamba could analyze a patient's vital signs,
Okay.
medication data, even subtle changes in their voice,
Wow.
to provide early warnings of potential complications.
That sounds like it could revolutionize patient care,
It could.
leading to faster interventions.
Yeah.
Potentially